welcome to my channel. In today's video, I will talk about SPF, DKIM, and DMARC. We will talk about the current challenges in email as a means of communication and the issues with email authenticity and delivery. Managing an email server can be daunting and frustrating. With all the blacklists and delivery issues, it's not an easy task. If an email does not get delivered to a user's inbox, that is a big problem. We will do a deep dive into what SPF, DKIM, and DMARC are, their importance, and understand how they can help us enhance email delivery and also combat spoofing, phishing, and spamming at the same time. We will also discuss the process to create SPF, DKIM, and DMARC entries. And then finally, we will jump into hands-on lab and configure SPF, DKIM, and DMARC for a demo domain, and we will also validate our authenticity and email delivery. Today, email is one of the fastest, simplest, and most used means of communication. As email has gained popularity over time, spamming, spoofing, and phishing has increased and poses threat to users while also increasing the challenges in email delivery for legitimate senders. SPF, DKIM, and DMARC, they work together and can be used to prove and protect a sender's authentication as well as integrity of the email message while also enhance the email delivery. SPF, DKIM, and DMARC, they work together and can be used to prove and protect a sender's authentication as well as the integrity of the email message. It also helps us enhance the email delivery. Let's talk about SPF. SPF stands for Sender Policy Framework, and it is an email validation protocol that is designed to detect and block email spoofing. It is a very simple and reliable method to combat spoofing. It is simply a TXT record on the domain's DNS entry that lists all the servers that are authorized to send email for the domain. An SPF record in a top domain automatically authenticates the subdomains. The receiving email server runs a DNS query against the sending domain's SPF entry to verify that the email is sent from an authorized sender. Now let's take a look at how an SPF record can be created for a domain. In order to create an SPF record for a domain, you need two things. First, you need to identify all the servers that should be authorized to send emails for your domain. Second, you need to determine the action to be taken for the emails that do not match the SPF entry. Creating an actual SPF record is pretty simple. You start with the version for the SPF record, you list all the servers that are authorized to send emails for the domain, and you end with the action for all the servers that are not listed in the policy. In this example rule, V equals SPF1 means that the SPF in use is version 1. MX means that the mail server or the mail extender for the domain is an authorized sender. The a:\extra.domain.com means that the servers that are pointed by an a record extra.domain.com are also authorized to send emails on behalf of this domain. Finally, the -all means that all other servers that are not listed here in this SPF entry are unauthorized senders. There are multiple keywords that can be used in an SPF record to authorize senders. The MX keyword allows the domain's mail extender or the mail server listed in the MX record as an authorized sender. The IP4 keyword allows you to list an IP address or a subnet as an authorized sender. A keyword allows you to authorize the servers listed in an A record to send emails. Include keyword can be used when you need to authorize external domains mail servers as unauthorized senders. Sometimes you might need to allow third-party mail service providers like SendGrid or MailChimp to send emails on your behalf. Even if you are not managing a mail server for your own domain, you may be using third-party services. For situations like that, you can use the include keyword, which allows external domains authorized senders to also be your domain's authorized sender. Finally, the all keyword can be used to define the policy for the servers not listed in the record. The -all means that all the servers not listed in the record are unauthorized. The tilde sign in front of the all keyword means a soft fail for servers not listed in the record. This means that the receiving email server may accept the email, but it is likely to be sent to spam or junk folder. The +all allows any server that is not listed in the record to be an authorized sender for the domain. Well, I don't think you would want to do that. You can learn more about the SPF record syntax at this URL, openspf.org/spf_record_syntax. Now let's dive into some details about DKIM. DKIM stands for Domain Keys Identified Mail. DKIM is simply a private and a public key pair. The private key is used to sign outbound emails, and the public key is published into the domain's DNS entry as a TXT record. Unlike SPF, DKIM requires configuration on the sending mail server. For this tutorial, we will configure postfix to use DKIM for signing outbound emails. The sending mail server checks the signing table, and if the from header matches the outgoing email, it signs the message and adds a DKIM signature header using the private key. Once the message is signed, the content of the message cannot be modified. If the message is altered in any way, the DKIM header will not match and therefore fail the DKIM validation. This helps ensure that the message has not been altered between the sender and the receiver. The receiving mail server, when receives an email, it looks up the sender's DKIM public key in the DNS. If a valid record is found, it decrypts the signature using the public key and compares it against a freshly computed version. If the two values match, the message is then proven to be authentic and unaltered. This is an example domain keys DNS entry. The record type is TXT. There is a selector, or the value in the host field is default._domain key for this example. The actual record starts with the v equals DKIM1, which simply means that the record is DKIM and the version is 1. The k equals RSA means that the key in use is RSA, and then the p equals actually holds the public key for that domain. Now let's talk about DMARC. DMARC stands for Domain-Based Message Authentication, Reporting, and Conformance. It allows senders to publish policies, which helps the receiving mail servers to determine if they should rely on the SPF and DKIM for the domain. It also defines what action should the receiving mail server take if the email fails SPF and DKIM tests. When a destination email server receives an email, it looks up the sending domain's DNS entry for a DMARC policy. If a valid DMARC policy is found, then email server will take actions for the failed emails based on the DMARC policy that is published for the domain. The DMARC policy contains information on where to send feedback. A feedback email report is also sent to the published email address to notify of action taken by the receiving email servers. Therefore, the DMARC policy ultimately helps enforce the email sending policy. There are two types of enforcing mode for DMARC policy. One is the strict policy, and the second is the relaxed. Strict policy means that the signing domain must exactly match the domain in the from address. The relaxed policy, on the other hand, means that the from address can be a subdomain of what is specified in the policy. Like I mentioned earlier, DMARC also has an action policy specified in the record. It can be one of the three modes: report-only mode, quarantine mode, and reject mode. The report-only mode is specified by the keyword p equals none. The email is accepted irrespective of whether or not the policy matches, and a report is sent to the sender. Quarantine mode is specified by P equals quarantine. The email is quarantined and normally sent to the spam folder of the recipient. In the reject mode, which is specified by P equals reject keyword, the connection is actually aborted and the email will not be accepted for delivery if the policy doesn't match. For all three modes, if you have an email address published in the DMARC policy, a feedback email is sent back. You can start with the report-only mode and then slowly ramp up to quarantine and finally to reject mode after validation and confirmation. Here's an example of a DMARC policy. The record type is TXT. The host field has the value of _DMARC, and the actual DMARC policy starts with a V keyword, just like SPF and DKIM. The V equals DMARC1 just signifies that the record is a DMARC record and the version is 1. The P equals reject in this case specifies that the DMARC policy is to be run in the reject mode. And then the RUA equals mail to report email at sender.com specifies that the feedback email should be sent to report email at sender.com. So RUA equals mail to keyword is where you specify the email address that you would like to receive the feedback to. Now to the exciting part. I know you've been bored with my talk and have been waiting for this. Let's jump into the actual configurations. We will start by creating an SPF record for the domain. Here I'm logged into my DNS control panel. We start by clicking on the Add New Record. Select the TXT record. For the host field, we just put the @ which just means the entire domain. For the value, we are going to start with the V keyword. V equals SPF1, meaning we're using the SPF1 version. Then we authorize the mail extender. Then we authorize the mail.tripaba.com A record, simply because the mail extender is pointed to mail.tripaba.com. It is not directly pointed to an IP address. Based on my knowledge, pointing the MX record directly to an IP address is a bad practice, and some mail servers do not like that. So I have my MX record pointed to an A record, which in turn points to an IP address. Because of that, we have to authorize the mail.tripaba.com A record into the valid list of valid senders. Then we end our SPF with the -all keyword because we do not want any other servers to send mail for this domain. Now we select the TTL to be 1 minute for this example. You can just leave that to default and save it. And that's it for the creation of the SPF record. You can actually use online tools that are available for you to generate SPF record. This MX Toolbox SPF record generator is an example. Then there's also the spfwizard.net. So if we use this wizard to create the SPF record for us, allow MX server yes, and then the mail.tripaba.com for the action, we will do the fail. Non-compliant will be rejected. So that you can see that this wizard also created the exact same SPF record. So it's up to you. You can either manually create the SPF record if you are comfortable. If not, you can use any online wizards or tools that are available to generate an SPF record for you. And that's it for the SPF record. Now it is the time to configure DKIM on a postfix mail server. I have this mail server ready to go, but if you would like to learn more about how to build an actual mail server, you can watch my previous video titled Build Your Own Mail Server for $5 a month. As you can see here, we are on a CentOS 7.5 release, and we will be using OpenDKIM to configure DKIM signing on our outbound emails. Since we are on a CentOS server, we can simply run yum install OpenDKIM to install OpenDKIM on our server. Let's go ahead and accept. Now that the OpenDKIM is installed, we can see that there is an opendkim.conf file in the etc directory, and it also creates OpenDKIM directory on the etc folder. So the etc OpenDKIM directory has a keys folder and a couple other files. Let's start by creating a backup of the original configuration file. cp etc opendkim.conf, and we are going to say .oris. So now we should have opendkim.conf and the oris file. Let's take a look at the default OpenDKIM configuration file. The configuration file is pretty well documented, and you can probably understand different configuration options just by reading this configuration file. The default configuration file will mostly apply to us, and we will make some changes, but I'll start by emptying out the configuration so we can start fresh. We'll start with a command line, say DKIM configuration. Just like the default configuration file, we are going to start with the PID file configuration. PID file, point to var run opendkim, opendkim.pid. This simply points to the PID file for the OpenDKIM. Next, we configure the mode. The default OpenDKIM configuration file has the mode set to V, which means verify, but we are going to update this, so we use the SNV, which means sign and verify. Next, we use the syslog configuration, set it to yes, set syslog to yes, so we can log the activities to syslog. We also want to log the success to syslog, so we'll set the syslog success to yes. We also want to enable log Y, which will give us some more details about why or why not a message was signed or verified. Then we specify the user ID for the OpenDKIM to run as, which is going to be OpenDKIM in this case. Next, we define the socket, which is going to be the default 8891 at localhost. Then we define the UMask for the socket created. So the UMask is set to 002 so that the MTA, or the postfix mail transport agent in this case, is able to access the socket because the postfix runs as a non-privileged user. Now we configure the OpenDKIM to send reports to the senders if their reporting email address is published. Then we set the software header to yes. So this just adds a DKIM filter header field to the messages that pass through this filter. It helps identify messages that it has been processed. Then we use the canonicalization. This option is set to both the header and the body of the message, separated by the slash. So for example, relaxed/relaxed. So one applies to the header and the other applies to the body. There are two options. There's the relaxed option and the simple option. Simple option is more strict and does not allow any changes to the header or the body of the message and can cause problems with mail relays and stuff like that. So it's recommended to set this to relaxed. This option allows minor changes to the header and the body of the messages. Then we define the selector. We just set it to default. We specify the minimum key bits that we want to use, 1024. Now we'll add the oversign headers to the from field. It just lets prevent the malicious signatures to the header fields, in this case the from header field between the signer and the verifier. Then we enable the query cast to the OpenDKIM so it can cast the DNS queries. And we enable auto restart just in case the OpenDKIM crashes. Next, we define the key table, pointed to OpenDKIM key table. If you remember, there were some files, the key table, signing table, and the trusted host files created by the default installation of the OpenDKIM. So we are just going to point the key table to that same file, key table. This simply tells the OpenDKIM where to find the keys to sign the messages. Next is the signing table. Signing table. It's going to be RE file, etc OpenDKIM signing table. The signing table directive defines a table that is used to select one or more signatures to be applied to the message. It just tells the OpenDKIM how to use the keys mentioned in the key table. And then the RE file option here means that we can use regular expressions or wildcards in the configuration file. Then we define the external ignore list, also going to be the RE file, etc OpenDKIM trusted host. So this directive identifies a set of external hosts that may send mail through this server. Make sure my spellings are correct. Then we want to define the internal host. Internal host, this is also going to be the RE file, trusted host. The internal host directive identifies a set of internal hosts whose mails should be signed rather than verifying those messages. Let's go ahead and save it. Now we need to configure the postfix to talk to OpenDKIM for signing outbound messages. Postfix main.cf. We'll start with the comment DKIM configuration. We'll type smtpd underscore milters. We'll point that to the socket that we created, 8891, and that's the port where the OpenDKIM will be listening on once we start the service. Non-smtpd underscore milters, going to be the same smtpd underscore milters. Then we say the milter underscore default underscore accent is going to be accept. The end of DKIM configuration. Let's double check smtpd milters, non-smtpd milters. It's pointed to the smtpd underscore milters and accept. So that's it for the postfix configuration. We'll go ahead and restart the postfix or reload the changes. Reload postfix. Now that the postfix is configured to use OpenDKIM and the configuration has been reloaded into the postfix, let's go ahead and generate the keys for our domain. We'll go into the etc OpenDKIM folder and the keys folder there. Let's create a directory to hold the keys for our domain, baba.com. We'll go in there. We will use the OpenDKIM-genkey command to generate the keys. -b. So -b options, we can specify the number of bits we want to use for our keys. We will use 2048. -d is the directory where we want to store. Actually, we are inside the directory, so it does not even matter. Otherwise, you could just we could just go back here. We can say OpenDKIM -genkey -b 2048. We'll specify the D or the directory. .com -s is going to be the selector. We'll just use the default selector. You have to remember though, whatever selector you use here needs to be used everywhere, including your DNS record. So now if we look at the chipaba.com folder, we have two files. The default.private holds the private key, and the default.txt has the public key. Let's cat the default.txt. Oops, that's inside the chipaba.com default.txt. So this has the actual public key, or actually the DNS entry. If we had a Joan file to update, we could just simply copy and paste this, but we are using a third-party DNS provider. And because we use the 2048 bits in the key, this is split into two lines. We have to actually merge them manually. Let me paste it here. So this is going to be actual selector that we will put in the host field. We'll put this in the host field. Our DNS entry is actually going to start here. We need to these codes, and we also need to remove this line here. Make sure I have the word wrap on. So this is actually our DKIM public key that needs to be, or the DKIM TXT record that needs to be published. So I'm back to my DNS control panel. Click on add new record, TXT record. Host is going to be the default _ domain key. Paste it there. For the value, we're just going to put this guy here and set the TTL to 1. So that's it for the publishing the DKIM DNS record. Next, we also create the DMARC policy. So let's go ahead and do that as well. For the DMARC, we are going to do _DMARC. And the actual value is going to start with v equals DMARC1, just like the SPF and DKIM. We specify the DMARC and the version number. P equals, it's a policy. We can define either none, quarantine, or reject. So we're going to do the reject in this case. Then you specify the RUA, where you specify the email address for receiving the feedback. So we'll do the demo@tripaba.com. I actually created that email. And that's it for the DMARC record. So let's go ahead and publish it. So we have the SPF record created. We published the DKIM DNS record with the public key. And we have the DMARC policy published as well. All we have left to do is configure OpenDKIM to actually sign the outbound messages for the tripaba.com domain. Back to the configuration file. Let's see, OpenDKIM.conf. We already have everything configured and ready to go for the OpenDKIM, but we still need to configure this key table, signing table, external ignore host list, and all that. So let's go ahead and do that. So open up the key table where we'll specify what key to use. Just like we see in the example, we'll just do default._domain key .tripaba.com, and then tripaba.com default selector is going to be etc OpenDKIM keys tripaba.com/default.private. So that's the location of the private key. Save it. Next, we configure the signing table. So if you remember, we configured this as RE file. So we can use the wildcard. So we can say *@tripaba.com default._domain key .tripaba.com. So this tells the OpenDKIM to sign all emails on tripaba.com domain. So we'll save that. Now let's take a look at the trusted host. So we just need to make sure that the local host is there, and we also want to include our tripaba.com in there. So that's it for the OpenDKIM configuration. Let's go ahead and start OpenDKIM. It's not a service, CentOS 7.5. So, I mean, service would still work, but OpenDKIM. And let's verify that the OpenDKIM is working. We can see that the OpenDKIM is listening on 8891, where we configured our postfix to communicate with the OpenDKIM for signing the outbound messages. Now that we have finished the configuration of the OpenDKIM and the postfix mail server, now let's do some tests and validations. So I've got some online tools here. So I've got the SPF query tool, where we can query our domain to see if we have a valid SPF record. Let's go ahead and do that. We can see that the SPF record validation passed. Let's check the DMARC. we can see that our DMARC record is valid as well. And now let's see if we can validate by actually sending an email to this email address. Compose, send an email to this email address, DKIM, SPF, DKIM and DMARC for tripaba.com. Checking SPF, DKIM and DMARC for tripaba.com. Let's go ahead and send this email. Oops, looks like the SMTP service unavailable. We are unable to send our email. Let's check what could be wrong. Okay, looks like we did not change permission for the keys. Let's go ahead and fix that real quick. Open DKIM, grab the keys folder. If you remember, we configured the OpenDKIM to run as OpenDKIM user when we created the tripaba.com folder inside the keys directory. We did not assign the permission. So let's go ahead and fix that. So we'll make it owned by OpenDKIM. Actually do it recursive. Tripaba.com. Let's make sure we have the right permissions now. Okay, so the OpenDKIM should now be able to read. Let's go ahead and try to send that email again. Send it, and now the message was successfully sent. Let's view the result. Email validation result. We can see the DKIM signature. We can see that the DKIM result is pass. SPF is pass. Message is not marked as spam. So we can see that, we configured DKIM, DMARC, and SPF for our mail server, and then we can see that we passed everything. So this actually validates the authenticity, meaning that the email was sent by the authorized mail server for the tripaba.com domain. So with the proper DKIM, DMARC, and SPF configuration, it is more likely that the email gets delivered to a user's inbox. There are other factors that affect the delivery to the inbox versus the spam folder, but this should help quite a bit. Now let's see if we can check our score as well. This is a mail-tester.com. I kind of use this to check how my email deliverability looks like. Go ahead and compose to that email address. Checking the deliverability for tripaba.com. Testing now. Go ahead and send it. And let's check our score. And you can see that we got 10 out of 10 for our deliverability. So you can check, it also displays all the, we can see our messages, spam session likes us, and then we're properly authenticated, passed the DKIM signature is valid, the SPF is passed, message passed the DMARC test. We are not blacklisted. Message could be improved, of course, because there is no HTML version of the message. So there are other additional factors that will cause or contribute to your email deliverability. But this is a good start and can greatly enhance or improve your deliverability. It'll also protect your identity. Once you have the DKIM, DMARC, and SPF published into the DNS records, then anyone else sending an email claiming to be you, that's invalidated, and you are actually protecting your identity. So that's how you configure DMARC, DKIM, and SPF for your domain. If you have any questions, leave a comment. If you like this video, please like, share, and subscribe. And I will see you in the next video. Thank you for watching.